In this demonstration, we are going to take a look at developing static classes for our applications. A static class is a special type of class where all of the members are static. That includes fields and properties as well, not just methods. This particular class called program, this is a standard console application, has a static member in it. However, the class itself is an instance class. We could theoretically create an object of type program. Whereas a fully static class, you can never use in a constructor call. One of the most useful static classes is console. If you were to take a look at its definition by hitting F12, you will see that the console class is a static class. It is actually marked with the static keyword, and everything within it is also static, including all of the properties. As you can see, there are a series of properties here, some of which are read and write, some of which are read only, and then all of the methods are static as well. This allows you to start using the methods of the class without creating an instance of it first. And it also limits the memory graph of all of the member items. So there is only ever going to be one input encoding property. There's only one caps lock. There's only one cursor top. So we do not have multiple versions of these properties or fields. We don't have any fields listed here, but all of these properties are in memory only once. With an instance class, any instance members, such as a field or a property, there is one for every instance you create. And that makes sense. If you have a person class that you want to store in a list, a series of them, you want every person to be independent and have its own memory. But a static class works very differently. We're only ever going to have one copy of any of its members in memory at any time. With that, we can create our first static class and use it as a place to store global data. As a matter of fact, we'll call it global data. Then we can prefix it with public static. And now any field or property I add to this class, there will only ever be one of them in memory. So anywhere from within this program that I access a particular member, they will all be accessing the same value. I don't have to worry about one area of the code reading a value out of here that's different from when another area of the code reads this very same value. So again, it's going to emulate global variables. So I could say public int global int. And I can make it a property or I can make it a field. And then for this to be legal, because it is a static class, what do I have to do? I have to mark it static. And then from program or anywhere else, I have this global data class, and I can set a value to it, or I can read a value out of it as such. And it'll be accessed the same way no matter where I am in the program. The only difference may be is if I have different namespaces in this application, I may have to put a using statement up at the top to include whatever namespace that class is included in. But global data is part of the same static classes namespace as program. So I have nothing to do here because they're part of the same namespace. I'm not limited to what data types I can use. If I needed a list of values as well, I could create a list of strings, and then I'll call it names. like this. And I can also assign default values. They're standard properties. In this case, I'll just create a new list of string, and I better return that closing curly brace I accidentally deleted earlier. Another nice feature about static classes is we are allowed to create a specialized constructor for this type of class, and we'll call it static global data. And if I wanted to, I could move the initialization in here. And that would be perfectly acceptable. This static constructor will be called the first time we try to access any of the members of this class. So I don't have to worry about this ever being null then. It'll automatically be called. I will never actually say global data something like GD is equal to new global data. It will not happen because it is a static class and I can't use new or a constructor call on it. But the CLR will automatically fire this constructor off the first time we try to access anything inside this class. As a matter of fact, you might think, well, don't we have to mark that public? As a matter of fact, no, because the access modifier is not allowed because this is something that is strictly under the control of the CLR. Let's create another static class. This one I'll call MathUtils, short for Math Utilities. And this class, we are going to put several mathematical methods in here that solve common formulas that are found in algebra and other disciplines. Something you may find useful when you are writing your software. So you may decide, I'm doing a lot of stuff with geometry. I'll need to calculate the area of a circle many times. This would be an ideal place to put all of these methods. So we can create a public static double, call it circle area, which accepts a radius, and we return math.pi, that should be math.pi, times radius, which is radius squared, and that is the formula for calculating the area of a circle. What about circumference? That could be something useful. I'll copy that method. Instead of circle area, we'll call it circle circumference. We still need a radius. This time it's going to be 2. Let's make it 2.0, explicitly make it a double. And it'll be pi times r. Very useful. What about static double rectangle area? This time we're not going to just need a single radius, we need a width and a height. You might use different names, but we still get the same result. We return width times height to get the area of a rectangle. What about the perimeter? Circumference of a circle is basically the same as the perimeter of a rectangle. It's the outside edges. So perimeter. This time it's going to be 2 times, we should probably put the 0 in there, width plus height. As you can see, we're building up a series of useful methods that we can use in our software. We could also add constants to this. We know that there is a math.pi constant. If we go look at the math class, you'll see that is also a static class. So in a way, we're just building on its capabilities. It has very useful methods as well. A lot of them are dedicated to trigonometry. Some are for calculating minimum, maximum, ceiling, rounding. but it has these two constants, e and pi, which are very useful. However, in your program, you may need derived values of pi, such as 2 pi or pi over 2. So maybe we want to define, so public const double. So maybe we want to define several of these predefined constants so we don't have to do the math at runtime. So let's call this one 2 pi. Maybe we can use a little I. And we'll set that equal to math.pi times 2. So anytime we need this calculation, 2 pi, we now have a constant we can use. And a constant works well with a static class because in a way it is static as well. This constant is only defined in memory once, and actually that's kind of invalid, that statement, because it's not really created in memory. Constants, when you compile your code, are embedded directly into the output, the value. So when we have this return math.pi times radius, when this is compiled, this math.pi is actually substituted with the 3.14, etc. value. So math.pi is not what is in the output code. It is only in the source code, so we can read it by name instead of by number. The same would happen if we use 2 pi. And maybe we'll have pi over 4, or pi over 2. Let's just do pi over 2. So we could say pi over 2. So instead of pi times 2, it'll be pi divided by 2. And then there could be pi over 3, pi over 4. There are other also very useful constants you may want, such as public const double, and we'll call this one radical 2. And for this one, we need to determine what the value of the square root of 2 is. Now, we could try to calculate this on the fly, but the problem is you can't do calculations at a constant, not the same way as you could do, like this is just multiplying by a literal. But this, like calling math.square root of 2, that's just not legal. So what we'll do is we'll bring up the calculator program in Windows and make sure you're on scientific. We'll click 2, and then we can find the square root, and there is the value. So then we can copy it, and I'll paste it here. Now, clearly we're not going to be able to use all of these digits. If you look at math.pi, it holds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16 decimal digits. So we'll follow the same pattern. So we'll take it out 16. And since the next number is less than 5, we can just delete that. And that'll be a fairly good approximation of the square root of 2. We could also rename this if we want. We could say square root of 2, but radical 2 also gives the correct meaning. We could also find other very useful calculations that we may end up using a lot in our code and put them here. But I think you understand where this is going. Now we have our mathutils class, and we can get value of pi over 2, radical 2, 2 pi. We can call rectangle area, supply it 2 values as such, and we can keep enhancing this class with more methods until we reach a point of satisfaction where we've solved all the problems we need to like this, and eventually we could even take this class and put it in a library so it can be called at will from other programs. Let's take a look at one more static class. We'll call this one console helpers. As you know, the console class allows you to read in data from the console, but that data always comes in as a string. What happens if we wanted a routine that would allow us to specify a prompt and then have it continually read in that string from the user until the correct data type and range was passed in? We can create a method in our own static class called console helpers to do just that. We're going to do it using several techniques. First, I want to be able to use different colors for the prompt and what the user types. So I'm going to create some state information. So public static console color, and we'll call this one prompt color. We'll have a get and a set. And then we'll have an input color, and then finally an error color. And we can define these to be, let's call this one white for the inputs, or for the prompts, and then how about yellow for the what the user types, the inputs. And then finally the error color, well, I think red is a logical choice there. So we have made 3 static properties, and they're public, so they're accessible to the outside world. Now let's create a method that will allow the user to request an int. So public static int will be the return type. We'll call it getInt. If you wanted to be CTS friendly or common type system friendly, maybe you'd call it getInt32, because that is what the int data type is. If I go to source for int, you can see the name of the struct is int32. It depends. We're going to use it only in C#, so getInt is sufficient for my needs. Then we're going to have a string called prompt. Then we need to have a series of values indicating what the minimum and maximum values are going to be, such as int min value, then int max value. Now, we don't necessarily want to have to require these values. We could instead set a default to int min value and max value constants. That way they only have to actually put in a prompt, and then anything that's legal for an int would be legal for the result. But if they did change it, let's say they only want between 1 and 100, then they would supply 1 for minimum value and 100 for max value. As I said, we are going to repeatedly ask the user for a valid int. So we know already there's going to be a loop. So we will say bool quit equals false. Then we'll create a do loop while quit equals false. Now, you could also change this to while not quit. They're both equivalent, but I think this kind of is a little closer to what we intend when we read this verbally. So do while quit is false. So that means we're going to keep doing something in here until we explicitly change quit to true. Well, what are we going to do? Well, we know we need an int value. So I'll define it outside of the loop, and we'll call it result. And let's just set it to 0, just some default value. I could, of course, set it to default int as well. That is also going to return 0, but this may fit better with our template if we decide to create other get methods then we don't have to change it from 0 to something else. We can just specify default whatever this data type happens to be. And we know at the end of the method we're going to return result. So that will get rid of our error that we had here because now we are actually returning a value. So what are we going to do inside of this loop? Well, the first thing we want to do is retain the color of the console before we start changing the colors. So we don't know where they were prior to executing this method. So we want to store that somewhere. Let's actually do that at the top. So console color original equals, not console color, we just want the console dot foreground color. Then before we leave the method, we will set this console foreground color back to the original. It's always good to clean up after yourself. So inside this loop then, we are going to change the color. I'll just copy this line again to the prompt color. And because they're both static, this getInt method and prompt color, I could use them as if they were both instance members. Like a regular class, let's say the static was gone, you would use them the same way. So a static member can access another static member without any issues. So I set the foreground color to the prompt color, and then I'll output the prompt. Now typically, we're not going to want to do a console write. We're going to assume they want the input on the same line as the prompt. So we'll just issue a console write instead of a write line. Then I'll change the foreground color once again to the input color. And instead of writing this time, we are going to do a read line. So this is what the user will input. Now we are going to check to see if the value entered is an int. To do that, we'll say if int.tryParse the input value and then out result. So this will indicate it is a legal result. Else, this is where it's not legal. So it's not an int. Now we're going to change the foreground color to the error color, and then console write line, the value must be a valid int. So that was a failure. But because we're not changing quit from false, we are going to continue executing this loop. It'll just go right back up to the top and do everything again. Okay, what happens if the try parse succeeded? That means at least result is a legal int, but we're not done because there's no guarantee that what they entered is within the range of min value and max value. So that's what we have to do next, is test that. If result is greater than or equal to min value and result is less than or equal to max value, then we have success. What can we do? Well, we want to make sure we get out, so we'll set quit to true. And that's really all that needs to be done. Else, we have another error now. Instead of just saying the value must be a valid int, we're going to indicate that the value must be between min value and max value. So that is the error if they put in a value that's outside the range that's specified. At this point, we are done with this particular method. We can go back to program and then ask for an int. Call it I is equal to console helpers dot get int. And then I can specify, please enter a value between, I got to get rid of one of these quotes, between 1 and 100. And I'll specify 1 for min value and 100 for max value. They're both inclusive, so as you saw here, we are checking greater than or equal to min value and less than or equal to max value. Clearly, if I switch these around to 101, then we would have an issue because I don't think our loop condition would ever be satisfied. So we could enhance our program to make sure that min value and max value are correct. In other words, the min value has to be at least less than or equal to max value. Otherwise, like I said, we could run into an endless loop because we'd never satisfy the results. So let's go ahead and run this. You can see, please enter a value between 1 and 100. Let's give it an A. As you can see, it's yellow. So the value must be a valid int. Okay, let's give it a valid int, negative 100. The value must be between 1 and 100. Okay, fine. How about 50? That it accepted, and we're now on the console read line. Probably would have been helpful if I said, replied in some way, you entered I. So let's type in 50 again. You entered 50. And notice here, it put the color back to gray, even though we changed it between white and yellow. And in the previous example, we did white, yellow, and red. So it's perfectly able to go back to the original color, so you don't have to worry about it out here. So the nice thing is now, anytime we want to call that method and get an int from the user using the console, we only have one line of code. We can just read it. Let's say we didn't want to have to type in console helpers dot every time we wanted to call get int. We can use a using static clause at the top, supplying the entire namespace and class name for console helpers. Then this statement is equivalent. So when we call this get int, just like whenever we create another type from another namespace, it scans for all of the namespaces we have using statements for to see if this class, console helpers, contains the get int method. So it takes one step or some of the typing out of it, making this an even easier technique to employ. And just to show you how useful that console helpers class can be, we can copy that method and now simply change the int to a long. And everywhere you see ints in here pretty much are going to do the same thing. And it'll be long try parse. Must be a valid long. And just like that, using the same basic template, I now have the ability to request a long value from the console. Guess how hard it would be to do a double? I think you're starting to see the pattern here. So we can do a double. And we again have a min and max value for double. The good news is most of the numeric data types have the min value and max value constants defined. So change this to double. The good news is once I change this result and I change this double, it's going to complain everywhere I don't have the correct data type, oops, in use. I meant to just change this over here. And change that to double as well. And now we have the ability to prompt the user to input a double. And again, it's just a single line of code from where we call this. So we have the get int. Oop, I better change that to get double. Doesn't help that I just changed the data type, so I should change the method name as well. And this should also be get long. And I suppose if I wanted to, I could also just change it to get value, and then they'll all be overloads of the same basic pattern, except with a different data type for the inputs, like this min value and max value would then indicate which one of the methods to call. But I think I'd like to be explicit here and just call it get int, get long, and get double. Then from program, we could say double d is equal to get. You can see now those three methods are showing up because of our using static statement above. So get double, then give it a prompt. Please enter a double. And we could not limit it by not supplying a min and a max value, so they can literally enter any double. And then you entered D. So I run this, so enter a value between 1 and 100, 50, enter a double, 1.2345 minus 10. And that is a legitimate double value. And just like we did with the get int, where we typed in an illegal value and we got an error message, the same would happen if we entered an illegal value for the double. It'll give you an error message that appropriately says the value must be a valid double. So static classes really do have a great impact on your software. A lot of times it is going to be reserved for utility classes and methods such as the console helpers and math utils that were defined within this project. However, you might also use it for other things like a data access class. So if you want to supply a single method for all of your classes to call to access data in a database, a static class might be the best choice, because then you limit access to it via one instance, which is the static instance, so you don't have too many database connections open at once. You can limit the number of simultaneous queries, etc.